Hello viewers, welcome back to the YouTube channel. In this video, we're going to talk about Docker volumes. Docker containers are by default stateless. What do I mean by that is you would not be able to persist or save data beyond the life cycle of them. So for instance, if you have a container up and running, if you go inside that, make some changes, create some folders and files inside it, and if you shut the container down, you would not be able to recover your data. You're going to lose your data forever. And this isn't a problem. I mean, this is by design. This is how Docker containers are designed to be. They are decoupled from the storage. And it is pretty easy to attach volumes. Multiple containers can also share the same volume. Let's first head over to the terminal. Let's understand the problem practically. I'm going to type Docker images. It's going to show me all the images that I have downloaded from Docker Hub. I'm going to type run. Run basically is the command that is used to create containers from images. I'm going to say Alpine latest. Alpine is a Linux distribution which is lightweighted, and size of the Alpine Linux distribution is somewhere around 5 MBs, so it's very lightweight. Now I am passing some parameters or arguments. I'm saying -I for interactive mode, T for terminal, and I'm also specifying the sh, which is the shell. I can run this command right away, but I would like to give it some name. This is optional. I mean, if I do not specify any name, Docker would come up with a random container name. I don't want that to happen. I'm going to call it Alpine container and press enter. It's saying that the image does not exist locally, so it's going to download the image from the Docker Hub on demand. It has just created the container. Now I'm inside the container. You see the pound symbol here, which means that I'm the root user, or I have the highest privilege in this account. If I type who am I, it's gonna say root, and I am in the root directory. Let's create a folder inside the Alpine and let's call it volume. Inside volume, I'm going to create a file. Let's call it matrix.log, and I have Vim installed already on Alpine. So I'm gonna say vi and then the name of the file. Okay, now the file has opened. I'm going to press I for edit mode, and now I can type whatever content I want to be there. Now I'm done with editing. I'm going to press escape, then shift colon, then W for write, and Q for quit. If I want to see or check the content of the file, I can type cat command and then the name of the file. Now I'm going to type exit. That will put the container in background, meaning that I'm going to stop the container. If I type ps, it's going to give me the name of all the containers which are currently running. But you know that Alpine container is not in the list. It is because Alpine container is stopped, and in order to see that, I need to pass -a command, which stands for all. Here we have Alpine container. I can either copy the name or simply copy its container ID. Now I'm going to shut down the container. You will see that you would not be able to recover the data. I'm going to type docker and then container, rm stands for remove, and then the container ID. If I type the same command again, you would not see the container anywhere. Now let me go ahead and again type in the same command. If you really want, you can rename it. I mean, you can give a different name to your container, but that is not necessary. I am again inside the container, and if I type ls, you would see that the volume directory that we created in the previous container is not here. That means we have lost the data when we kill the container. Volumes come in rescue. We can create a volume, we can attach a volume to a container. Not only this, we can attach a volume to multiple containers, meaning that we can share the volume. We actually can mount a physical location of a folder within the container. So we're going to see all these things happening. Let me clear the console. Just like before, let me type exit command and docker -a to show all the containers. Let me copy the container ID and kill the container. Let me type docker volume. This basically is a sub menu within the Docker. I can either type docker volume or -- help, both are the same. The Docker sub menu is quite simple. It has only 5 commands in it. So let's go through them one by one. If you want to see all the volumes on a system, then type docker volume ls command. So I have these 3 volumes created. I do not need the test volume, so I'm going to delete this. For this, I need to type docker volume, and then the RM stands for remove, and then the name of the volume that I want to delete. It has just returned the name of the volume, which means the volume has been deleted. Now let's create a new volume. So the command is docker volume create and then the name of the volume. I'm going to call it volume test. You can type volume ls to see all the volumes. We also have prune command. This command is used to remove or delete all the unused volume which are not being used by any of the containers running. Last command is inspect, probably the most important command. And if you are interested and want to know more about the volume, you want to peep inside the volume, then you can type docker volume inspect and then the name of the volume you want to peep into. So this has returned us a JSON-like syntax. The most important property is the mount point. The mount point is the most important property, which refers to the location where the data of the volume is stored. But here's the catch. Even if I want to go there, I would not be able to do it on Mac machine because Docker on Mac uses a virtual file system. So even if I say where live and Docker, there is no Docker folder inside the where live because Docker on Mac is using virtual file system, but there's a way to go there and actually be able to edit the data of the volume, but that is not recommended. This is bad practice. Volumes are not supposed to be edited manually. They are managed and created by the Docker itself. They are within Docker storage directory. So now you know about Docker volume. We have just created a Docker volume. Its name is volume test. Let's attach a volume to a container. Let me clear out the console. Now let me type in docker run command to run a container from Alpine image. I also need to specify -i and t, the sh for shell, just like before. But this time around, I'm also going to attach a volume with this container. For this, I can either type ~volume or for short -v. This is my preferred way of doing this. Next, we need to type in the name of the volume we have just created. That is volume test. And then type colon. The second half or the right hand side of the colon belongs to the path of the container. And everything after the column is the path which belongs to the container. This has to be an absolute path. I'm going to create a folder called volume and data inside it. Just like before, I am now inside the container and I can type ls, but you will see This time we have a volume folder created. Let me go inside it, and there also should be a data folder created. Just like before, now let me create a file inside this. And let me open this up with the Vim editor. I am inside the edit mode. I can type in anything I want. Okay, now I am done with editing. I'm going to press escape, then shift colon, then W for write and Q for create. I can check the content of my file with the help of cat command. Exit container. We are now out of the container, and I can type ps-a to see all the containers. Let me copy the ID of the container that I want to shut down. I have now killed the container. Now let me do the same thing, but this time around I'm going to give it a different name to my container. So what we did last time, we created a new container from Alpine image. We attached a volume, and its name was volume test. And when the container was up and running, we went inside the volume/data folder, created a file there, made some changes, and exited. If the volume thing works, that means I must be able to preserve my data. If I am reattaching the same volume to a different container, I should be able to get the data which was saved last time. So let's press enter, and I'm inside the container, and here we go. We see there's a volume directory. So let's go inside the volume and data. There should be a file, matrix, and let's see its content. Here we are. So this is how we can save and preserve our data from being lost beyond the life cycle of a container. Now let's talk about how can we share the same volume among multiple containers. The idea is the same. Instead of using one container, we're going to use more than one container with the same volume. Let me go ahead and attach the exact same volume, and this time around I'm going to create a new container. Let me go inside the volume and data folder and make some changes in the file we created earlier. Okay, now we are done with editing just like before. I'm going to save and exit from the file. Let's exit from the container as well. If I type ps-a, now you would see there are two containers. Now we have two containers which have been stopped. The Alpine _ container _2 and Alpine _ container _3. Both have made some changes into the volume. Last time we made some change from container 3. Since container 3 and container 2 both have been attached with the same volume, so they both should be able to access it. So these two containers are stopped. One of them was created a minute ago, another was created 42 seconds ago, right? So let me bring them up by typing docker and start command. Let me copy the container ID. Okay, now docker is up and running. If I type ps, then you should be able to see the container. Let me type docker exec. This is the way of communicating with the container. We actually can get inside the container. Let me type I for interactive mode, T for terminal, and the name of the container ID. Okay, the program is sh for shell. Now I am inside the container. Let me type ls again. Let me go inside the volume and data. Let me see what's inside the matrix.log. Okay, it's saying that hi, this is some changes the Alpine container made. This actually should be 3 because I have just opened the Alpine container 2. So now you got the idea that I have a single volume which is being shared among 2. You can share it among 3 and as many containers as you want. So now you can preserve the data, and you know that how you can share the data by attaching the same volume among multiple containers. Now let's understand how can we bind a actual physical folder onto a container. Let me type docker run command again. I'm going to say -i and t and -v. But this time around, we do not need to bind, or we do not need to attach the Docker volume, because as we know that Docker volumes are managed and created by Docker itself, but we want to bind or mount a actual physical folder. And for this, I need to specify absolute path of that folder. So this is the folder that exists on my local machine, on my host machine. Actually, the data folder inside i9 folder does not exist, but don't worry, Docker is going to create that folder for us. The volume/data also does not exist, so Docker is going to create that as well for us. And that's it. If I enter, I am inside the container. You will see that there is a volume folder already created for us. Let me go inside volume and data folder, and just like before, let me create a file, a very simple file. I'm gonna say hi bind mount file.log. So it's going to create a file.log, and it's basically going to send I bind mount string into that file. If I type cat, I look into the content, I have hi bind mount data inside the folder. Now let me also do one thing. Now let me open this location on my host machine. Now you see I am inside the i9 folder. A folder called data has been created. Let's go inside the folder, and there is a file.log file. I can delete the content, write whatever I want to write. So this is the content that I have just written, and I'm going to save it. And the same change should be available inside the file.log file. This is two-way sync. Changing the data from container reflects on my host machine, and if I do change the content of the file from the host machine, it is reflected from the container. This is how we actually can mount a physical location of a container.